Hi friends, welcome back. So this is a second project of supervised learning. I hope you remember that last project we have done on linear regression where we had a problem with e-commerce data, right? But this time we are going to do with logistic regression where the domain of the project is marketing. So basically we are going to predict customers response to particular product with the help of logistic regression model, right? On our marketing data. So let's start with one by one. Again, as we usually do, we will have some problem statement, and in that flow we will be solving the problems. So let's start with first. It is asking that import the necessary library. So what we need is, again, we are ignoring warnings, right? Then we need numpy, regular expression, pandas, right? scipy.stats for applying the statistics, matplotlib.pyplot again for plotting our all the plots, seaborn for the visualization, math, right? We are getting factorial. Okay, then pylab we are getting rc parameters, and from rc parameters we are defining the figure size here, right? So you can see that it is 10 by 15. Now we are importing train test split from sklearn.model selection. Then we are applying logistic regression in this problem. So obviously we will import it from linear model, and some other thing like classification report, confusion matrix, RCC curve, ROC curve, accuracy score, right, AUC. So all these we will import from matrix. Now what we are doing is we are displaying the first 5 rows and last 5 rows of the data frame. So first thing, we will import the data set. Again, I'll provide the link of the data set in the description. You can check out it from there, right? And secondly, we are getting top 5 rows, so that is applying df.add n equals to 5. So here you can see that this way we got the 5 rows, and these are the columns or the attribute that we have: id, year birth, education, marital status, income, right, kid home, teen home, dt, customer, recency, right, so on so forth. And if we go tail, so top 5 tail are, you can see here, right, how the value is we have. Now the third step, it is asking that check the shape of the data, right, number of rows and column, and check the general information about the data frame using .info method. So what we have done here is we have defined a function here, that is basic info, which will check the information and shape about the data frame, right? And we are getting a copy of our data frame, right? So we are taking temp, so it will take the copy where we are passing deep as true. Again, what the deep will do is data will be copied, but the actual Python libraries, we can say, or the core thing, that will not be copied recursively, right? Now the print that we are doing is just printing the df.shape, and this is the method to print asterisk 30 times. So you can see that here the asterisk is printed 30 times. And now printing df.info, so here you can see the information of our data set. So here you can see again these are all the nominal values. You can see that the data type is also given here, the columns that we have, rows that we have, right? Now what the observation we can get is, from the above information we can see there are some categorical column like country, dt, customer, income, education, marital status, right? And we will do some hack to convert them into numerical variables, right? So we'll see how can we achieve that. And it seems like there is no missing values. Let's verify it by checking the percentage of each column. So again, fourth step, it is asking check the percentage of missing value of the data frame, drop the missing value if there are any, right? So again, we are making a normal function to check the missing data in percentage. So we are defining the function, passing the data frame here, and printing percentage of missing data of data frame. And here we are applying the formula, that is df.isnull. If there are any, do sum of them and divide them the length of df right? To get the percentage, just multiply that with 100. So this way you can see that in income you can see that there is 1% of null values, and rest of the attribute there is no null value. So here you can see in the above, none of the column has missing value except income, and the only 1% in the income column we will drop all the missing values. So what we can do is we can just use drop na. So df dot drop na, where we are passing in places true, so these will be deleted permanently from our real data set. Now checking the missing values, that is df, right? So here you can see that this time we have removed all the missing values from all these columns. Okay, so the fifth step, it is asking that check if there are any duplicate rows. So how we can achieve that? Again, making a simple function to check duplicate, passing the data frame here and telling that okay, duplicate equals to take duplicate from this df, right? And where df dot duplicated value is associated with the data frame, and return all that duplicate data frame. So here now we got the duplicate value and we are check the duplicate from df. So again we are having or storing these values into duplicate. If we print the duplicate, so here you can see that the data frame was empty because we don't have any duplicate rows here, which is a good thing for now, right? And now that means it is good to go. Sixth, it is asking that remove the extra space in the income column name. So there are spaces in the column names. First let's remove the unnecessary spaces from the column names, and then we will convert the income column. So df dot columns equals to, so here you can see that all the columns that we have are given here. Now df, we are defining remove space. So we got the column here. Now removing space, again we are defining a function here which will help us to remove spaces from the name of columns, right? So you can see that if I go with this one, so you can see that this is space here, right? And if you also check that, yeah, so far we have found with one column, right? But we are making a generic function which can apply with all. So what we are doing is df dot columns equals to df dot columns dot str dot replace. So where there is a replace space is identified, just replace that with nothing. That means cut that space, right? So again df dot column, we are string dot replace, right? So this way we can return our df, actual df. And finally we are passing our df, which is the data frame that we have removed the space inside this. So here you can see that the space is removed now, right? Now we have successfully removed all the space from the column name. So this way you can achieve that. So this is how the beautiful function, we only didn't notice the income column, but this is a generic. Whenever you pass any other data frame in this code, so that will also work with that, right? Now you can see that seventh is it is asking check the data type of value in income, right? And convert the value in income column to numeric format. So here you can see that defining map income, right? Again making a function here, try catch, the block is here, and passing the x, right, in the map function, because it is asking check the data type of value in column income and convert the value income column into numeric format. So we are doing this in try except. Again x equals to x dot strip. The strip is nothing but, let's say if there are any beginning or any trailing, that means at the end of any such values are available, it will remove that, right? And the sub that we are using, the sub will do nothing but it will replace all this string with this and return them, right, which is passed via x, and returning that as a float. Okay, so if there is any error, now what it will run, it will run np dot none for that. Now we are making a df dot income, right? So we are storing df dot income map, right? And we are calling this map income. Okay, and next thing you can see that the basic info df, right, we are getting asterisk as 40 times now. right? And df dot head equals to n equals to 6, so it will also return that. So first you can see that the df dot info in our print statement, and secondly the df dot head that we got here. Now let's start with the further part, that is EDA and basic statistical analysis. So we haven't yet reached to linear regression, but yeah, the process will be same for every statement because the data that we have is quite balanced. But if you work in real life example, you may not get the balanced data. You will have to make the data ready for further proceeding. So this is why these steps are very important, guys. So let's start with the eighth one, that is it is asking check the basic statistics of the data frame using describe method. So again, what the describe will do, so we are making a function for basic statistics, passing the df and checking df dot describe dot transpose, so it will return all the values of our describe function. So we are calling the function that we just defined here, passing the df here, and you can see that we got the description of the function or the described value. So count, mean, standard deviation, interquartile ranges, right, for all the respective columns. Ninth, it is asking that write a function which will take the data frame as input and will plot a bar plot which represent the percentage of distribution of each level of education column, right? So what we will do is we are making a function again. So this is percentage education, which function it will return the percentage information regarding educational background of each customers, right? So we are making a copy of our data frame, right? And we are telling that okay, define a new variable ed data in which we are counting the values of educations in our data frame, right? And then we are telling that in our ed.df that we got from here, and in frequency percentage just round the value. How? So I is dividing by the ed data education of sum, and right, we need up to 2 values, and for I in ed data education in this variable, okay? And then we are printing ed data first. After that ax is nothing but it is for plotting now. So df dot education dot value counts, right, dot plot. So how the plot is our bar plot this time, and the figure size that we want is 8x5, color that we want is slight blue, and font size is 14, width is 0.6. We are passing the title of our ax. So the title is percentage of education data distribution, font size is 14, right? And totals that we are defining list, and now the loop starts from here. So for I in ax dot patches, for every patches what we are doing is we are appending the value that we get from the get width, okay? And similarly for p in x patches, this time we are getting the x dot annotate, okay? And we are annotating the values, right, up to the get height, and right, the value will be plotted at height in the percentage, okay? And the font size for them will be 12, right? And this way x dot set y label count, so for y label we are giving count. So finally we, if we check that this is the function call that we have, right? First thing, you have seen that we are printing the ed data here. So here you can see that the gradient, phd, masters, graduation, phd, masters, second cycle, basic, and this is the education, and these are the frequency percentage, right? And now this we will print in our bar plot. So here you can see that if we print it in our bar plot, so these are the count in y label, percentage of education distribution in x label. This is how the graduation, phd, master, second cycle, and basic is plotted, right? And finally the percentage for that, okay? 10th is write a function which will take the data frame as input and will plot a bar plot which represents the percentage of distribution of each label of country column, okay? So here you can see that defining percentage country df. So df equals to df dot copy, again deep equals to true, cu data equals to df dot data frame, right? Country, that is value counts, okay? And cu data, we are saying that okay, frequency percentage will be equals to round I divided by cu data, country sum where for I in CU data country. Okay, now printing again the CU data that we have done in last step as well. Okay, but this time we are getting the percentage for country. So the rest steps are almost same that we have just seen. So here you can see that, but this time we are changing the color. Here you can see that all the country SP, SA, CA, Australia, India, right, Germany, US, so on. So country is you can see that the code and frequency percentage that we have. Now if we see it in the bar plot, so here you can see that the nicely it is distributed, and the highest percentage of country of data distribution is our SP, right, which is 1000. Next thing what we will do is we will it is asking do a bivariate analysis between country column and education column, plot a bar plot which will represent all the education level of customers country wise, and which country has the highest graduation customers. Okay, so here you can see that this is defining cross country education percentage. So passing DF here, and again doing the same thing, but the slide different will be in our figure size this time, and the color code that we are giving here, right? So here you can see that the country cross tab perk dot plot kind equals to bar size is this, colors that we have the colors in our list, right? Font size is 40, and rest thing is almost same. We are defining the title, we are passing the Y tick, right, passing X tick. So and here you can see that country that we have, right, but this time it is concatenated, right? Education with Australia, then second cycle education with second cycle with Australia, then basic with Australia, then graduation with, let's say, India, then masters with India, then PhD with all the country. So this way we will get this plot. So here you can see that how nicely it is plotted now. So the color code we have provided for each country to distinguish it. You can also remember this same trick or get the code from the video. Okay, but please do it by yourself so that you will get a hands-on experience on it. So the color you can see that the US. So first we check with the second cycle. So the highest is for SP here, right, that is 48%, and the lowest is for Australia, that the lowest is for Australia, yes, that is 3.5%. Secondly, the basic, that the percentage of frequency of graduate in different countries, so it is SP, that is 51%. Then in graduation again it is SP, that is 48.9%. then masters again it is 46.8%. then PhD again it is 52.18%. Now question number 12 is do a bivariate analysis between marital status column and education column, plot a bar plot which represent all the education level of customers marital status wise, right, which marital status has the highest percentage of graduates. So here you can see that crossing the cross mark education percentage DF. So you are passing all the values here, marital status, education, so on so forth, right, and again passing the color code here, but this time we are plotting it in a different style. So here you can see that this time all the U's are here. Okay, education, and first you can see the statistics here. What we got is education marital status, right, absurd, alone, divorced, how many are married, how many are single, how many are together, widow and YOLO. Okay, and then you can see that how nicely it is plotted. So the highest number of status, if we check for the graduates in different countries, so it is for YOLO, right, it is green for our PhD holders. Plot a percentage segment graph between the marital status and education of customers. So defining the crossbar graph, marital status, education here, that is DF. Now DF dot equals to DF dot copy, again that is deep equals to true, PD dot cross tab, so again passing DF marital status, DF education dot plot bar, right, stack equals to true, and PLT dot legend, that is title equals to marital status versus education, and showing the plot. So here you can see that passing the same function. You know what the beauty of this code is, that we have defined every problem in a function. So it is not only restricted to this code or this problem statement for marketing with linear regression. You can do with your own code as well, right? Own CSVs as well. So here you can see that observed, alone, divorce, marital status, single, and this time the bar plot is plotted in this way, right? Now plot percentage segment graph between the education and country of customers. So here you can see that defining cross bar graph, education, country, right? Passing the df here, and you can see that df equals to df dot copy, deep is again true, and def pd dot cross tab df education, df country, and plot bar where is extract is true, and plt dot legend where we are saying that title is country versus education, and plt is shown here. So here you can see that second cycle, basic, graduation, masters, phd, everything is here now. Now the next step, it is asking data preparation and model training. Finally we are now close to applying our linear regression. So first thing it is asking in this part, third part, that is plot a count plot of target variable. So for that first we have to define our response, right? So here you can see that, okay, plot target equals to df we are taking copy of actual data, then sns dot count plot df dot response. So plot target df called function here. So 0 1, you can see that these are the response. So it seems like our target variable is completely imbalanced. So here you can see that, right? So here we have 0 value are very higher, 1 value are very higher. If we check the information, so again you can see that the response that we have 2216, right, the column. So for the time being it is eliminated id, year, birth, and dt customer, because here you can see that we actually do not need it, right? So this will definitely help to balance our data. Now what we are doing is we are taking a backup of our data, which is very important whenever you alter your data, of course with in place with true. So this way you will lose the information or other thing that might be required for future. So second, we are dropping the id, year, birth, dt, customers, country, education, marital status columns, right? So this way df dot drop, pass all the columns here, x is equals to 1, that is column, and in place is true, that means we want to delete them permanently. Okay, finally df dot info. So here you are passing the information, right, getting the information from here. Now new df, again taking df copy, right, new df dot shape, you can see that head we are getting the head values. Now third, it is asking that store the target variable, target column into response, that is the target is our response of course in the y variable, and the rest of the column in the x variable. So how you do that? First defining y, so in y we need only response, and in x we need rest. So what we will do is we will df dot drop rest values, and that will contain our x. So this way we can segregate our y and x here, right? Hope you got this easily. Next is x dot info. Again if we check the info, all these column have been removed. Now we are checking x dot shape and y dot shape. Okay, so you can see that this is perfectly fine, that we got the shape, and getting the new x and new y to get the matrix values, right? It is in a matrix format, and also creating the reshape of y, right? So let's see what happens further. So the fourth step, it is asking that split the data set into two parts, that is 70% train set and 30% test set. Guys, in this sample we have written it 70-30 because we had the slight idea about it, and in your case if you are working with any other data set, you will have to check that how portion you need for training set and what portion you need for test data, right? The random state, that is 42, again that will not change our value time and time, and train a logistic regression model and print the accuracy score, classification report, ROC, AUC curve for both the train and test set. So this is what our aim of this video. Okay, so you can hope you have noticed that till here we have done a lot of things which are basic but very required. Okay, unless and until we do not score a correct or much higher accuracy, right? So again, defining a function here, define model train evaluate, passing new x and new y that we have just created, right? You can see here. And then x train x test, y train y test for train test split, passing new x new y. The test size is 0.3, that means 30% is test size, and obviously the remaining 70% will be our train size. Random state is 42, again to keep the state of our train test split as it is. Now LR, we are taking logistic regression. Penalty, we are passing 12, and class weight we are giving balanced. So these are the parameters that we can pass, but we can also go with empty, right? It will also work in that case. Secondly, lr.fit, we are fitting the logistic regression in our x train and y train. Now we are getting the y prediction from train, so lr.predict x train and lr.predict x test, both will be predicted. So how we will get that? The train accuracy score we will get from accuracy score y train y prediction train. Test accuracy score, we will get accuracy score from y test y prediction test. Printing asterisk 60 time. Next time we are doing train classification, getting classification report in y train and y prediction train, right? And again printing asterisk 40 time, then test classification report, classification dot report y test y prediction test, again printing asterisk 60 time, and finally printing the ROC curve. So how the ROC curve will be printed? So here you can see that we are defining y train prediction, lr dot predict probability of x train, right? X test predicting probability of x test, then train FPR, train TPR, train threshold, that we all are getting of our ROC curve, right? So in ROC curve we are passing y train prediction, the values expect 1, and then test FPR, test TPR, test TS threshold, we are getting ROC curve, right? Y test prediction. Okay, so start from 0 to last -1, right? And then plotting it as a train FPR, train TPR label, that is train AUC plus a string we are passing AUC. So in AUC function we are again passing train FPR and train TPR that we got from here. Now plt.plot, so it will be plot for test FPR, test TPR, where label equals to test AUC. str, that we have AUC, that is function of test FPR and test TPR. plt.legend, plt.x label, that is threshold, plt.y label, that is AUC, plt.title, that is AUC plot, and plt.grid, plt.show function that we finally called. Again calling the function that we just created, and let's observe the accuracies. So first, the train accuracy that we got is 74%, the test accuracy that we got is 71%. If we check the classification report, so you can see precision recall, F1 score, and support. So all these values you can see the accuracy, micro average, and weighted values. Okay, test classification, the precision, recall, F1 score, and support vector you can see here. And finally printing the ROC curve. So here this time you can see that this is the final model or the final prediction of the ROC plot that we got is this one. So here you can see that how similarity it is in the train and test, where the train accuracy that is 76% and the test it is 75%, right? So this way you can analyze any data set with using supervised learning techniques. So this was all about the market data set, right? We have done the linear regression in it as well. We have done logistic regression here as well. Okay, so yeah friend, thanks for being with us. If you like video, please do like, share, comment, right? So that will help us and motivate us to give you more content regarding AI. So hope you are already aware that future is all about AI. So this is how these skills are must to have, right? We know that some skills are good to have and some are must to have, but these seems like should be must to have if you are working with technologies. So thanks for being with us. We will come up with another video soon. Stay tuned. All the best. Thanks.